welcome to your second lesson. In this lesson, we're going to be talking about Chapter 1, Lesson 2, which is about complex fractions and unit rates. Our objective is actually to be able to simplify complex fractions. What that really means is we need to be able to divide fractions that are complex. Our standards that we're going to be addressing today is 7th grade standard ratios and proportions standard number 1 and 7th grade number system standard number 3. So we're going to go ahead and get into this lesson. So the next part of our lesson is vocab. Go ahead and copy down the definition that you see here. Go ahead and pause the video, copy everything down. I did include an example for what I'm going to talk about in this vocab word. There's actually 3 examples here. So a complex fraction is our vocab word. It's a fraction, a over b, where a or b are fractions and b does not equal 0. So what that's saying is this could be a fraction or this could be a fraction. But the bottom number here is not allowed to be equal to 0. They both actually could be fractions too, as we can kind of point out here in a few seconds. Some examples of a complex fraction are 1/2 divided by 2. So if I take a half and I divide it by 2. 3 divided by a half. 1 1/2 divided by 1/4. And we're going to learn how to solve problems like these complex fractions in this lesson. We're not only just going to solve these complex fractions, but we're also going to learn how to turn those into a unit rate. So make sure you pay attention, follow along, and I'll teach you how to do this. Alright, so we're moving on to our first example. In this first example, it's actually from here to the left. I added something that's going to help us later on so you don't have to see me writing that. So in this example, it says that we're going to simplify 1/4 divided by 2. I always like to say that if things look like they're stacked on top of each other, it's like a hamburger, because we have the bun, we have the meat, we have the cheese, we have the other bun, so it's all stacked on top of each other. I don't like to look at problems that are written going up and down. So one of the things I recommend is anytime you're seeing it all stacked on top of each other, that we actually turn it sideways and write it like a hot dog. So this is hamburger, we're going to change it to hot dog style. And to do that, we're going to write it like a mathematical sentence that just goes long ways. In this case, this says 1/4 divided by 2. So I'm going to rewrite that in a mathematical sentence. 1/4 divided by 2. Okay, so I just rewrote the problem. I'm going to make these a little bit darker so we can see them. 1/4 divided by 2. Now, I added a little side note that's something that we can use to help us. It says to change a whole number to a fraction, we divide it by 1. And that's because whenever we have a fraction divided by a whole number, we actually want to change that whole number to a fraction. So we can make it a fraction divided by a fraction. So I'm going to go ahead and put this 2 over 1. So now it says I have 1/4 divided by 2 over 1. Just so you know, we did not change this. 2 divided by 1 is still 2. All we did was write its fraction form. Any number can be written as a fraction as long as we divide it by 1. And we'll be using that method a lot in this one. Now, one of the rules that we have is whenever we have a fraction divided by a fraction, we actually have to multiply by the second fraction's reciprocal. Reciprocal means when we take this fraction and we flip it. So I'm going to give you a rule of thumb to do whenever you have a fraction divided by a fraction. Here's an acronym that we're going to use quite often in this class. KCF. Not Kentucky Fried Chicken, but keep, change, flip. That's what these 3 letters stand for. The K stands for keep. The C stands for change. And the F stands for flip. And this is something that we can do, this rule right here, KCF, anytime we have a fraction divided by a fraction. What it stands for is this. If I have 1/4 divided by 2 over 1, I keep the first fraction the same. 1/4 stays 1/4. Change. Change my sign. That's what change means. I'm going to change the division sign to a multiplication sign. And flip. Flip means we take the fraction that we have and we flip it. So I have 2 over 1, and now I'm going to flip it so it's 1 over 2. Now, all you have to do is, since I have a fraction times a fraction, we just multiply straight across. 1 times 1 is 1. 4 times 2 is 8. So 1/4 of 2, or 1/4 divided by 2, is 1/8. And that's how we're going to solve these problems. We're going to KCF them. Keep, change, and flip them. So make sure that you're ready to write them hot dog style and KCF after we change our whole numbers to a fraction. Alright, so we're now on to our second one. In our second problem, we're going to do the same method that we did in the first problem. So first we need to write down everything from here going to the left. This stuff here was actually from our first problem. I just kept it because we're going to use those skills to solve this problem as well. So example 2 says we're going to simplify 2/3 divided by 6. Right now, I see it's written like a hamburger. My job, change it to a hot dog. So 2/3 divided by 6. Now it's written long ways, which is what I call a hot dog. Well, that's a fraction divided by a whole number. We just learned we're going to change that whole number to a fraction by dividing it by 1. Now it's a fraction. 6 divided by 1, still 6. We're not changing it. Alright, so now I have a fraction divided by a fraction. Anytime you have a fraction divided by another fraction, KCF. Keep it, change it, flip it. So we're going to go ahead and do that. Keep 2/3, change division to multiplication, and flip your second fraction. Now we just multiply straight across. 2 times 1, that's 2. 3 times 6, that's 18. So 2/3 divided by 6 is 2/18. But 2 and 18 are both even numbers. So that really means that we should simplify this down. 2 and 18 both divide by 2, because even numbers divide by 2. So I'm going to divide the top by 2 and divide the bottom by 2. 2 divided by 2, that's 1. 18 divided by 2, that's 9. This is my final answer. If you leave your answer like this, I will give you about 80% of the grade. You'll get a B. But if you simplify your problem down, you'll get that A. So make sure that you always look to see if you can divide the top and bottom by the same number, and that's how we actually simplify down problems. As we say, what can I divide out of top? What can I divide out of bottom? And make sure you do that to top and bottom. 1/9 is our final answer. Let's go ahead and go to example 3. For example 3, we're still doing a problem that does simplification, and it's still done the same way as previous, but now this one's written a little bit different. This says that we're going to simplify the number 1 divided by 1/2. So in this case, instead of us having our whole number on the bottom of our fraction, or our complex fraction, we now have the whole number on the top of our complex fraction. And again, it's a complex fraction because we have a number divided by a fraction. So I have the number 1. Again, we're written like a hamburger. I like to write it like a hot dog. So I just rewrite it how I say it. 1 divided by 1/2. Now right now, we're still working with whole numbers. And we still have to follow one of our rules that we came up in the previous ones. Anytime that we have a whole number, we want to change it to a fraction, so we're looking at fractions. To change a whole number to a fraction, we're going to divide it by 1. So even the number 1, I'm going to divide it by 1. And that's because 1 divided by 1 is still the number 1. Now, that's a fraction divided by another fraction. So we can go to our KCF rule. Keep, change, and flip it. So I'm going to go ahead and keep the first one the same, 1/1, change division to multiplication, and then I'm going to flip my second fraction. So instead of it being 1/2, it's now going to be 2/1. Now we just multiply straight across. 1 times 2, that's 2. 1 times 1, that's 1. And now we're going to simplify this down so it's no longer written like a fraction, because 2 divided by 1 is the number 2. So if I had one sheet of paper and I split it in half, I would have 2 sheets. So anytime we take one whole and we divide it in half, we end up with 2 pieces. And that's how we solve this type of problem. Let's go ahead and go to number 4. In example 4, what we're going to be doing is we're going to solve or simplify the whole number 4 divided by 1/5. Again, we're written like a hamburger. We're going to switch it to hot dog style. So I'm going to rewrite it. 4 divided by 1/5. I'm going to use those rules that we talked about in the first 3 examples. Well, that's a whole number. I'm going to go ahead and put it over 1, so now it's a fraction. Now I'm back to a fraction divided by a fraction. Since we're at a fraction divided by a fraction, you're right, we can KCF it. 4 divided by 1, keep it the same. Change division to multiplication. And now we're going to flip that second fraction. Multiply straight across. 4 times 5, that's 20. 1 times 1, that's 1. 20 divided by 1, that's 20. So what this means is if I had 4 sheets of paper and I split them equally 5 times, I would end up with 20 little small sheets of paper. For example 5, we're going to look at something that could be a real-life problem. Here it says Lola can jog 1 1/3 miles in 1/4 of an hour. Our job is to find her average speed in miles per hour. Now, we learned in the previous lesson, in unit rates and rates, how to change something when it says per hour. That means our denominator has to be 1. So we're going to use those skills that we previously had to solve this problem. First, we're going to write this like a rate. So we know that we go 1 1/3 miles. That's our rate at the top. And 1/4 of an hour. And we want to make the hours per hour, which means that the hours are going to be our number that's going to change to 1. So what we're going to do is we're going to approach this kind of the same way we did earlier, but also using previous lessons. So first, I'm going to write 1 1/3 miles divided by 1/4 hours. Okay, so we've written it like a hamburger. This time, normally we would take this and we would say, okay, well, to get rid of what's on the bottom, we have to divide it by itself. So let's go ahead and do that. Divide by 1/4 on bottom. Divide by 1/4 on top. Okay. Well, the bottom is actually a fraction divided by a fraction. Anytime we end up with a fraction divided by a fraction, we multiply by its reciprocal, or KCF it. So, this is really 1/4 times, because remember we changed in division to multiplication, 1/4 times 4 divided by 1. Now I'm going to go ahead and multiply that straight across. 1 times 4, that's 4. 4 times 1, that's 4. So on the bottom of this problem over here, I'm going to get 4 divided by 4. 4 divided by 4 equals 1. So now we have successfully changed the denominator to 1 hour. We're going to per hours. We're almost there. Now, this problem here says we have 1 1/3 miles, and it's going to divide by 1/4. We're still going to use the rule of KCF, but before we do that, this is a mixed number. We actually have to change our mixed numbers to an improper fraction, because the rule is we have to take a fraction divided by a fraction. We never said anything about a mixed number. So what we have to do is, and this is something that maybe you guys could write down, to change a mixed number to an improper fraction, we're going to multiply by the bottom number. So we take the whole number here, 1, multiply by the bottom, 3. 1 times 3 is 3. And then we're going to add the numerator. 3 plus 1, that's 4. But we have to keep the denominator the same. So it's 4 divided by 3. Again, we just take 1 times 3. I'm going to write that over here. 1 1/3. We're going to multiply. I'm going to change this one here. 1 times 3, that's 3. Add the top, that's 4. 3 plus 1 is 4. So this is really 4 divided by 3. So I have 4/3 miles divided by 1/4. Now it looks like a fraction divided by a fraction. So now we can go to our KCF rule. So in this problem, we actually did KCF twice. But before we actually did that, we had to change our mixed number to an improper fraction. And this is the reason why we call this improper is because if you look, the numerator is larger than the denominator. But this is still equal to that. All we did was make it a fraction. Again, 1 times 3, add the top, that's 4, good to go. So I have a fraction divided by a fraction, KCF. I'm going to keep this the same. I'm going to change this division, so I'm actually erasing it. Change division to multiplication. And now we're going to multiply by this fraction flip, because we changed it. Now we have to flip 1/4. Now, all we got to do, multiply straight across. 4 times 4, that's 16. 3 times 1, that's 3. Okay, so I have 16/3. This is not simplified. What I like to do to simplify an improper fraction, because we're not allowed to have improper fractions. Improper means that they're technically not right. It's not right to have a fraction that has a numerator larger than the denominator. So what I like to do is I always like to look at the bottom number, and I say how many times could I multiply this bottom number and to get close to this 16 without going over. What times 3 is close to 16, but I'm not allowed to go over? Well, the answer is 5. That's actually my whole number. So now I'm just going to multiply those. 3 times 5, that's 15. Well, the numerator was 16. How far away is 15 from 16? That's 1. So that really means that this would be 5 1/3. So if a student was going 1 1/3 miles in 1/4 of an hour, they could actually run or jog 5 1/3 miles, important to put labels on it, in 1 hour. All I did was change our improper fraction back to a mixed number. We'll learn how to solve some more of these in class. We're going to practice one more, and hopefully you guys are catching on. If not, that's absolutely okay. Make sure you guys come in with questions whenever we come back after this lesson. Alright? We're going to do one more. Don't worry. If you need help, I got you in the classroom. Let's go. On to our last question. In example 6, we're going to be talking about something that's real life that could be related to if you had a pet. And if you ever wondered, hey, if I buy this bag, how long will it last depending on how much I use? Well, this question is going to approach that, and this is where we're going to look at a complex fraction that actually solves a real life problem that maybe we could potentially have if we had pets and we were going to feed them the same amount of food every day. So here it says, Emily has a bag of cat food that contains 22.5 cups. If she feeds her cat a total of 3/4 a cup of food per day, how many days will the bag last? So again, as in our previous example that was like a word prompt, we have to first write this as a rate and then change it to unit rate to figure out how many days the bag will last. Because we're going to per day. Anytime we hear the word per, that usually means that our denominator has to change to number 1. So I know that I want days on the bottom. So in this case, we're going to put the 22.5 cups on the top. We have 22.5 cups over, well, that's 3/4 a day. So I'm going to go ahead and put 3/4 cup a day. So we've written a rate. Anytime we write a rate and we want to change the denominator to 1, reminder that we have to divide the numerator and the denominator by the bottom number, as we learned in our first example, our first lesson. So we're going to divide 3/4 by 3/4, and 22.5 is also going to divide by 3/4. Now, this is really a fraction divided by a fraction. We just learned in this whole lesson that the way we go about a fraction divided by a fraction is keep, change, flip. Keep the first fraction the same, change division to multiplication, and flip the second fraction. So we had 3/4. Now we're going to make it 4/3. Let's see if that does change it to 1. 3 times 4, that's 12. 4 times 3, that's 12. And 12 divided by 12 is 1. Alright, so we got 1 on the bottom. Now, we have 22.5 divided by 3/4. So we need to change that as well. Now, we learned that we're not allowed to have a mixed number. That's a mixed number. A whole number and a fraction, that's a mixed number. We're not allowed to have that. So I'm going to write down here 22.5. I'm going to follow the rule that we learned previously. I'm going to multiply by the denominator. 22 times 2, that's 44. And I'm going to add the numerator. 44 plus 1, that's 45. So what I really have is this is going to change to 45 over 2 cups. And if I took 45 divided by 2, I'd still get 22.5. Now, this now looks like a fraction divided by a fraction. So this is where we're going to keep, change, and flip. Keep this fraction the same, change division to multiplication, and I'm going to flip the second fraction. Now, if you're writing this in your notes, you don't have to erase this. I'm just erasing it because I really don't have that much room to do this. So it's always good to still keep the notes going on the side if you can. So I'm going to flip the second fraction. So instead of it being 3/4, it's now going to be 4/3. Okay, now the hard part. I'm going to multiply something large with something small. So I'm going to take 45 and I'm going to multiply it by 4. Well, I know that 45 times 2 is 90. And that was just 2. Well, I have 4. 4 is 2 times more than 2. So 90 times 2, that's 180. So this would be 180. Now, if you didn't know that 45 times 4 is 180, that's okay. You can always type it in your calculator and just check to see if you're correct. So I'm grabbing my calculator here just to check. 45 times 4. And in fact, I do get 180. So I'm going to go ahead and leave that 180 alone. 2 times 3, that's 6. I knew that one. So if I had 22.5 cups in one bag, and I took 180 divided by 6, well, I know that 18 divided by 6 is 3, and I have a 0, so that means 30. So if I gave a cat 3/4 of a cup of cat food every day, that one bag of cat food would last 30 days for one bag. Based on this information, based on how much we have and how much we're using a day to tell us how much we're going to have at the end. It would last 30 days for one bag. Alright, that's it for notes. Make sure you have everything. Make sure you're ready. If you have any questions, please write them down at the end, because remember, you are required to have at least one. And that one question is not something that you comment. I actually want you to ask it in the classroom so I can address it and we can spend that time trying to solve it. We will practice more of these in class. Be ready. Let's go. I'll see you tomorrow.